to speak a little bit about, I'll speak later on about what I do, but a little bit about a guy called Gregor Mendel, who was an Austrian monk living in a monastery in Bavaria somewhere. And he grew pea plants. He grew thousands and thousands of pea plants. And he came up with an interesting observation, and a very important observation, that you can have the two different types. There's lots of different types of pea plants, but there are two different types that he discussed, that he wrote a paper about. So one is a tall and short. So if you have two tall, the children will be tall. You have two short, the children will be short. It's okay. It's not as simple as that. So he discovered that you can have. There are dominant genes. There are genes that are always expressed, but also what's called recessive genes. Recessive genes are not necessarily expressed every single generation. So you can have actually the child, the product of two short plants, can in fact contain a genetic markings from before, from a generation before, from grandparents, if we want it for peas, that is then expressed later on. So if you have two pea plants that have recessive, for example, short plants, that's the gene markings that they have, so they will present, and they will create a short plant even though they're both tall. So that was his observation. He observed it over thousands of plants and he published it. And immediately his findings were ignored completely by the medical society just because he's like, he's a monk, what does he know? So years later, about 50 years later, his writings were rediscovered, and it's really what's called today Mendelian inheritance. So if you Google Mendelian inheritance, there's a website called Omim, which lists all of the genetic makeups of man and what every single strand of the genome will create in you, and depending on your coloring and your height and your intelligence and your capacity and what illnesses you're going to get. That's all basically connected to Mendelian inheritance. What's fascinating to me, hopefully, I hope for you, is that Chazal already spoke about this. Our rabbis already spoke about a concept of Mendelian inheritance. We'll give a couple of, there are a lot of examples in the Gemara, but we'll give a couple of examples that Chazal understood this, that there's a recessive gene. Right? The fact that we look like our parents, I don't know what your parents look like, but I have to guess that you probably look like them, right? Like either your mother or your father, one of your siblings. Okay, right? So that's simple, that we don't need to have Mendel to come and teach us. But the fact that there are expressions that are not necessarily seen in every generation. So my son asked me the other day, how come he has blue eyes if neither myself or my wife have blue eyes? So that's because a generation before, or even two generations before, there's someone in the family has blue eyes. So that's a complex genetic inheritance. That already Chazal understood. I'll give a couple of examples. The Gemara tells us that a woman tells the following story, tragic story. A woman gives birth to a son. They do Brit Milah, the son dies as a result of Brit Milah. So it doesn't say in the Gemara what he has. We can assume what he has is hemophilia. Hemophilia is a genetic abnormality dealing with blood clotting. So the person who has hemophilia, once he gets a cut, the rest of us, we get a cut, our blood, we have cells in our blood, which are called platelets, that cause the cut to heal. But a person who has hemophilia doesn't produce them, or they're not effective, depending on how we explain it. So they don't have that. They don't have that mechanism. So when you cut them, they bleed, and it doesn't stop. So the child, we do Brit Milah, which is quite a serious incision, and he bleeds to death. So the Gemara says that's tragic in of itself. We do Brit Milah again. Woman gives birth again. Another son does Brit Milah, and the child dies again. So the question in the Gemara is: do we do Brit Milah for the third child, or only after this happens 3 times? Because we know there's a concept in the Gemara called chazakah. Chazakah is what is the probability of something happening. So if something happens once, probably won't happen. It may not happen again. It happens twice, more likely to happen again. If it happens 3 times, then it's probably going to happen every time we do it, right? If every time if you wake up your roommate for shachar every day and you do it the first day and he hits you, you do it again, he hits you, he does it again, he hits you, the probably on the 4th day is going to hit you as well. That's a probability. That's called chazakah. Here we don't have a chazakah. We have 2 occasions that something happened, And therefore, theoretically, we should wait until the third occasion. Since it's called pikuach nefesh, since we don't want the children to keep dying, we don't want this tragic event to happen, so the Gemara decides that in fact, in this case, we don't need to have a chazakah. 2 children died, that's sufficient. So the third child is born, we do not do brit milah. Now, that seems to be pretty simple halacha. It's not so simple halacha. Because if you don't do brit milah, you're in fact chayav karet. It's one of the most severe things a person can do. It's like eating on Yom Kippur, it's not to do brit milah. Not only is it karet once, like eating on Yom Kippur, but every single day that a kid reaches bar mitzvah and didn't do brit milah, he's chayav karet every single day of his life until he dies. Right? So that's pretty severe, and we don't do brit milah on this child, not because we know he has an illness, but because his siblings had an illness. So what a chazal essentially is saying, we assume that there's a familial genetic abnormality, a genetic abnormality that affects, here in this case, families, and therefore there's a likelihood that it affects that sibling, and that's the psak in the Shulchan Aruch in Yoreh De'ah. But it goes even beyond that. The Rishonim then say, what about the following case? Look, this woman has a sister. Her sister gives birth to a son. Do we do brit milah for now the cousin of these children that died? What would you think? Do you think we do brit milah for them? What would you say? What?
Might say anything?
Yeah.
I think you would, right? Why?
It's different genetics.
Different genetics. Says the Rashba and various other Rishonim, and that's how the Ramah is posek, le'alacha, that we don't do brit milah for the cousin either. Now that's a brilliant idea. That was thought of well before Mendel. What essentially we're saying, it's not different. You said different genetics. It's not different genetics, because the recessive genetic abnormality that caused hemophilia agav is carried by women and affects only men. You remember the Russian royal family? What happened to the Russian royal family? What happened to? Why they not around? So what happened is that the women were all carriers of hemophilia. They were all cousins of each other. They all married each other, all cousins, and all the women had hemophilia. They were carriers, and the men got it, and they were born, and the male children were very weak. So the whole Russian royal family, and around the end of the 19th century, became very weak. And came a guy and said, "I can heal you." His name was Rasputin, and he said, "I can heal you. I have this magic powers to heal you." And that's how the beginning of the demise of the Russian royal family and the beginning of the Russian Revolution was, because they had hemophilia. So women are carriers; they don't get ill with it. Men get ill with it, and women are carriers. So the idea that the Rishonim are saying, that the Ramaz posek l'maaseh, is that a woman can carry even though she's healthy, and if she's carrier, there's a likelihood that her sister's a carrier because they both inherited it from their mother. So essentially we're drawing out a picture. If you go to a genetic counselor today, what they do is they take your family history and they'll draw a genetic picture of your family. So we're essentially doing the same thing. That's what they're doing. Right? That the Rosh was saying, here's the mother had it, she gave it to sister A, she may well have given it to sister B. And therefore, male child of sister B has as much likelihood of having hemophilia as child of sister A. And that's the halacha. That the first baby that's born to sister B, we don't do brit milah. So that's pretty amazing thing that Chazal is saying. Chazal is saying, we understood Mendelian inheritance well before Mendel grew his thousands of pea plants in Bavaria somewhere. Yeah.
But maybe it's not that they were so smart that like genetically that's how it worked. Maybe they just saw that whenever someone was a hemophiliac, their cousins died from the bris also. Maybe they're just thinking like, I don't know what this is, but we can't do that anymore.
But the truth is that even that observation in itself, which seems very simple to you, and you're probably right, I don't think they knew it from Gilui Eliyahu, I think they knew it from observation. But that observation wasn't copied in the medicine at the time of Chazal, neither was it in the Middle Ages.
Oh, okay.
So that observation
so they're the
itself
only ones that realize they have to
is a unique observation that they saw that people were dying. And there's not more hemophilia in the Jewish community than there are in other communities.
Right.
So that's I think an interesting observation. And even if you explain it very logically, which probably you're right, is that they observed it, they did that observation, and that had a halachic relevance. Give you another example. The Gemara says that a man should not marry a woman from Mishpachat HaNichfim. Mishpachat HaNichfim means a family that has a genetic abnormality. It's probably in that case something like epilepsy. So today we have treatment for epilepsy. So you guys can all go out and marry girls that have epilepsy. It's okay, don't worry about it. But what does Chazal say? They call it Mishpachat Anefim, not a woman who has a disease, but a woman who is from a family that has disease. So probably the same thing. They observed that in these families there's more likelihood to have a child that's got a genetic abnormality. So Chazal understood familial genetic abnormalities that was not understood or that wasn't recorded in medicine, definitely not in the Middle Ages, and not even until recently, even after Mendel published his papers, it wasn't accepted. You've existed the last example, and then we'll think how do we use genetics, what I do and how do we use genetics today. The Gemara says a very tall man should not marry a very tall woman, and a very short man should not marry a very short woman. Why? Because a very tall man, a very tall woman will produce very, very tall children, and a very short man, a very short woman will produce very, very short children. And we don't want to be too tall and too short. We want to be sort of Benoni. We want to be sort of in the middle. So again, they saw that there is inherited traits which are related not only to what you have, but somehow the combination of different genetic different genetic traits. That's not necessarily abnormality being short and small. Although now there's actually a big study that we're involved in now from Stanford University, which is they want to take families that have a very short, and they need to take families that have 10 or more children and to measure their heights. So there's not so many families in the world that have 10 or more children. There's a lot in Israel. So we managed to get a lot of Haredi families together and to give to have to spit, and every time they spit they get paid for it. It's like a good deal. If you're one of 10 children, I can get you a good deal. So you can be in this study. So they're trying to work now about the genetics of height and tall and short, and we don't really understand the genetics of height so much. So that's Chazal. We could go on, and there's lots of examples, and I think that's pretty fascinating because what I do, hear a little bit about, and I'll tell you now a little bit more about what I do, is to really show an interface between what our tradition says and what is being said today. But that's not so amazing, because at the end of the day, to say, oh, Chazal said something that's also said today, that's good. And as he said, we could explain it one way, we could explain it a different way. What I think is really fascinating is that Chazal not only spoke about these things, but he gave us paradigms to understand them. And what we're looking for today, very much in the area of genetics, which is a huge developing area, that we're able to do things today, and we'll speak about a few of the moment that we were not able to do even a relatively short time ago, and we think about where we're going to be in the future. We're looking for how can we use that technology, how can we use it, and how can we not abuse it. And I think that Chazal, in their understanding of reality, their understanding of medicine, their understanding of ethics, were able to give us that paradigm. I think that paradigm is very important and very exciting. So what do I do? So I'll tell you a little bit about Machon Puah, because the combination that we have of Limud Torah and the modern world, which is what I was told that's what we're talking about. So Machon Puah was founded over 20 years ago. We had very humble beginnings, but today we are in Yerushalayim, in a building that we basically do three things. We counsel couples in all areas dealing with fertility, sexual development, problems of intimacy, problems of genetics that we're going to speak about. So we counsel couples, and we get couples literally from all over the world, from throughout North America, South America, Europe, Australia, New Zealand. They have couples from just had a couple from Korea, from Japan, from Hong Kong, and of course throughout Israel. And the couples want to know, we're basically counseling in three areas. The first thing that we do is to explain to them what are their choices, let's say in fertility or in genetics that we're going to speak about. What are your choices, what are your options? And who's a good person to go to. So we do referrals and explanation of the treatment. The second thing we do, of course, is guide them halachically. What can be done according to the halakha? Not everything that can be done medically can be done halachically. And not everything that can be done should be done. We're going to speak a bit about that in a moment. And the third thing we do is also to become a shoulder to cry on, to be somebody to empathize with. If you've got them, if you know somebody, or you have yourself a genetic abnormality, let's say, you can't always share that with everybody. It's not something you tell all your friends. It's something that you need someone who's in there who can speak to you. Not always the doctor is so empathetic to be able to listen to you. And so Machon Puah is able to become that arena where people can share their frustrations, their difficulties, and can get some sort of guidance. The second thing we do is we supervise fertility treatments. Fertility treatments, there have been some very, very high profile cases. For example, there was a couple in Holland a few years ago that they went through a fertility treatment, and the woman got pregnant with twins. And when the twins were born, they ultrasounded them, everything looked fine, everything was okay. But of course, you can't see the skin color before you're born. You can't see that on an ultrasound. So when the children were born, they were very healthy, but one of them was white and one of them was black. And the couple themselves were white. So when they went back in the records, they saw on the same day that they'd had treatment, there'd been a black couple who'd been treated in the same lab, and obviously there'd been some exchange inadvertently of genetic material. Shmuel and I were involved in writing a series of articles about a couple who, John and, remember her name?
I don't remember the name.
Savage? Yeah. I don't remember her name. Who was a couple in America who, they were devout Christians, and she became pregnant through fertility treatment. And halfway through the pregnancy, the lab called up and said, "We're very sorry, Mrs. Savage, but there's been a mistake. And in fact, you're carrying somebody else's genetic material, somebody else's baby." And because she was a devout Christian, she didn't want to terminate the pregnancy, so she carried it to full term and then gave the baby up to the other genetic parents as an act of chesed. So we don't want those things to happen. Yeah.
Is the kid Jewish?
So that's an excellent question. As long as we back today, it's a complex. You can probably go online and find the articles that we wrote. You can discuss that. You can see. It's a good question. The couple, in this case, no, because the couple were not Jewish. But if it was a Jewish couple, it's a good question. So we don't want that to happen. So we supervise fertility treatments. We have today probably well over 100 labs around the world that we supervise, that we make sure that there's no such mistake, and we prevented mistakes happening. That a couple were about to receive the wrong genetic material, or that the lab, instead of throwing away a pipette, double dip, use it again by mistake, even though they're disposable, just because it's very, very busy, the labs. And so we prevent that happening. We have a system of supervision. And the third thing we do is education. We deal with education, research. We present at rabbinic conferences. We just had our own conference in Manhattan last Sunday, where we had over 220, 230 professionals come together to hear from the heads of the field about fertility and about supervision, about halakha. We present to medical conferences. We just we just had another paper accepted to a journal dealing with intimacy for older couples. So it's we try to have involvement in a lot of different areas, dealing with all very around this theme of fertility and genetics and related. So that's what we do. So I'm one of the counselors there, and I also deal with education, I deal with research. That's what I do. That's my job. So we're going to fast forward from Mendel and Chazal to today and say a little bit about genetics, because genetics is going to affect all of our lives. And as you grow up in your lifetimes, genetics has become even more important. We'll see in a moment why. So what is genetics? So everybody in this room, we hope, has in all of the cells that you have DNA, deoxyribonucleic acid, which is basically the map of what you're going to look like. Okay, with what is your potential in regards to intelligence, as we said, body weight, propensity to disease. Doesn't mean you're going to get the disease, you have propensity to diseases, etc., etc. So that's all determined by the map. We have a map, as we can imagine that I need to get from here to Tel Aviv, and I have no idea how to go there, so I plug into my GPS, the address I want to go, and it guides me on the map. That's what we have today. We used to have actually books. They opened up and there was a map inside. So the map tells you how to get from one place to another. If we come to build a building like this, we have to have plans. The plan tells the builder how to build. The DNA, the genetics, tells the builder, tells the body how to develop. And that comes with, it's inherited from our parents. We get 23 chromosomes from our father, 23 chromosomes from our mother. Together it's 46 chromosomes, which come together in pairs. So we have they're called very unexcitingly 1, 2, 3, 4, until you get to pair 22. And then pair 23 is called either XX, which will make you female, or XY, which will make you male. That's what it is. And it's really a map, and along those strands of that DNA is a very, very detailed map, which is extremely sensitive to how we're going to turn out. And in fact, Mendel didn't know about genetics. He wasn't able to look at the strands of DNA. That was discovered in the 50s by Watson and Crick. They won a Nobel Prize for that piece of work. And they and their work has really enabled us to now understand much more about genetics. And today, reasonably recently, we have mapped the entire human genome, which means that anybody here can go and take a sample of cells. That's very easy to get a sample of cells. You can give blood, has all your cells. You can get a swab from your cheek, will give all your cells. You can, every cell that you have should be pretty much the same. And they can then analyze that, and they can tell you what is your genetic makeup. And everybody's genetic makeup is somewhat different. Now, why is that important for you? Because in your lifetimes, what's going to happen is that's going to become public knowledge. They just have now had, there's a study going on in, I think in England, that they're looking for 100 volunteers who are going to give up their DNA, and that's going to be put public. So that we're going to try to see what's normal DNA, and it's going to be basically public knowledge. And when your DNA becomes public knowledge, your employer will know what genetic abnormalities you have. Your insurer will know what genetic abnormalities you have. Your health insurance will know what you have. So you'll now that will become very determined whether how much you pay for health insurance, where you are employed, where you go to the army. The army's not going to want to take someone who's got a propensity to certain types of diseases, because then they're going to get those diseases quicker for being in the army. So that's going to become it's becoming rapidly very, very important knowledge. And as I said, today we can map the entire genome. Yeah?
Can they enforce testing?
Sorry?
Can they enforce
That's a good question, how we're going to get to it, but getting more and more, you won't be able to get health insurance unless you do it. In the same way that today you have to sign a health form. You have to say, what I have in my family, etc. It's legal. You can't get health insurance unless you do that. So you're going to have that will become the norm in your lifetime.
So when you say
100%, that's clear. That's the case.
So when you say they know how to map the entire genome, they can take your genes and just tell you everything that you have.
They will tell you everything you have.
Can they tell you how tall you are?
So I'll tell you a story about that. My brother was working in the Salk Institute with Jonas Salk, is a double Nobel Prize winner. He has an institute in South California, and my brother was working there, and they had like a deal there that you could map your whole genome for $500. So yeah, $500, I'll map my genome. There was a woman in his shul who wanted to also map a genome for that, and then it was at the time. Now it's a little cheaper. Then it was $2,000 to map your genome. It was quite a lot of money. So the woman in his shul heard that he'd mapped his genome and said, should I do that as well? $2,000. So he said, your question, right? What information are you going to glean from there? And she said, well, I'll see that I have all sorts of propensities, all sorts of diseases. And he says, okay, what are you going to do with that information? So she said, well, if I know I've got propensity to diseases, then I will eat more healthy, I'll do more exercise. So he said to her, lady, I can save you $2,000 now. From now, eat more healthy, do more exercise. That's always going to be a good idea. So the fact you have a propensity to a disease doesn't mean you're going to get it in most cases. But if you, for example, why doesn't everybody who smokes gets cancer? Because some people have a propensity to get that and are more likely to get it, and therefore the trigger of smoking is more likely to induce in them lung cancer than there's other people. And that's the same in many, many other things. Some people have high cholesterol and they're perfectly healthy, and some people don't. So it's a combination of lifestyle together with propensity that's going to determine what your illness is. So you said, is it going to be forced? You want to know that information. If you know that I've got a high propensity to get diabetes, which is the largest epidemic in America today, so you're going to be at a younger age more careful about what sugar you intake and how you live your life, because if you don't, you're going to go blind very quickly. So we are going to want to know that information, and that information is crucial to our lives. So that's what's out there today, and that obviously, and you can see from your startled faces that's kind of frightening, that information, right? It's great to know that, but what does that mean? Everybody's going to know everything about me. I'm going to be exposed to the world. So we haven't yet got there that we're mapping everybody's genome routinely, But we are doing something else, and it's something that's very, very important, and it's very important in the Jewish community, and I think it's very important for people of your age as well. About maybe almost 30 years today, more, there was a man in New York, in Brooklyn, who he and his wife just got married, young couple. They had a baby, and the baby died. And in discovering what the baby had something called Tay-Sachs. Tay-Sachs is a genetic abnormality. You've probably heard about it. It's one of the most common Ashkenazi genetic abnormalities. And what it basically means is everybody in this room, we hope, if you don't have Tay-Sachs, and if you're here at this age, you don't have Tay-Sachs. So you may be a carrier, but you don't have it. So what it means is that all of us can break down fats. We ingest fat, we eat fat, and we break it down so we don't get fatty deposits around our body. Someone who has Tay-Sachs doesn't have that ability. So they're born perfectly healthily, because there's nothing wrong with them. But then they can't break down the fat. So they ingest fat by milk, by mother's milk has fat in it, everything you have in the world has fat in it. So they're not able to break that down. So after a few months, the child builds up fatty deposits around its body, and that affects its internal organs, and the child dies within a year, 2 years, 3 years, the child dies, and it's a very painful death. And this young man observed his child dying of this terrible disease. And he said, I'm going to be the last person, the last Jew this is going to happen to. So how can we get rid of that? Well, let's understand a little bit about genetic inheritance. We mentioned it, but we'll talk about it a little bit more. There are some genetic traits, when I say abnormalities, that are dominant. That's the same of hair color, that's the same of eye color, that's the same as build. Certain things you're going to see that's just dominant, that all the children will have. Being gingy, being redhead, that's a dominant genetic trait, it's not an abnormality, it's perfectly normal. Then you see a lot of women who have red hair, their children will have red hair. That's a perfectly normal thing. You have a red hair?
I have a red-haired wife, no red-haired kids.
No red-haired kids. Okay, so it doesn't happen every time. That's usually a dominant genetic trait. There are certain other dominant genetic traits which are simple. You can see there are other things called which are recessive genetic traits. So what are those? If dominant genetic trait, only one partner has to have the trait, and you'll give it on to your children. A recessive genetic trait is only expressed if we have what's called two carriers. Why? Remember we said that the DNA is in pairs? So sometimes the pair, if it's a recessive genetic gene, having half a pair doesn't make you get the disease. It just makes you have it in your body. So all of you have genetic abnormalities, but they don't affect you because they're recessive. The dominant genetic abnormality, even having one strand of genetic trait will make it express itself. And so recessive genetic traits or genetic abnormalities like Tay-Sachs, which is a recessive genetic abnormality, will only affect a child if both parents are carriers, which means both parents have the strand that's tainted. And being a carrier isn't a problem. We all have genetic abnormalities. There was a paper published in the British Medical Journal about a year ago that said that every single human being has about 300 genetic abnormalities. So I was discussing it with my cousin who's a genetic counselor, and she said that paper is completely wrong. It can't possibly be. It's much more like everybody has 3,000 genetic abnormalities, right? We don't have a perfect genetic abnormality. We don't have perfect genes. That's, as we said, we're trying to look what's considered to be normal today. That doesn't affect us, where there's small, irrelevant genetic abnormalities. And to be a carrier doesn't affect you. It does affect you if you have a partner who's a carrier. So Rabbi Eckstein, who saw his child die of Tay-Sachs, came up with a brilliant idea. If we can identify genetic abnormalities that are recessive and are common in the Jewish community, like Tay-Sachs, and we just say to you, let's test everybody. It's a very easy genetic test. It's a blood test. We'll take a blood test on every single person, and we'll test you. If you're a carrier, we'll just tell you, don't marry another carrier. Know that you're a carrier. You can't marry another carrier. That'll be fine. Right? It's a great idea. And he went to, and because he wanted to get rabbinic approval, he went to all the Rabbanim, and all the Rabbanim came out against it. Said if you can't do that, it's a terrible thing. Why? Because you're going to tell somebody you're a carrier. Now remember the Mishnah we said? The Mishnah says don't marry a woman from Mishpachat HaNichfim. Don't marry a woman who's got a genetic abnormality or from a family that's genetically tainted. By making now people are not so smart as we hope that all you are, and understand that people don't recognize there's a difference between a marker between being a carrier and being ill. You've got a marker, you're positive at Tay-Sachs, so you're something wrong with you. You're Mishpachat HaNichfim. And they didn't want to create more and more and more Mishpachot HaNichfim that no one's going to want to marry them. So they said you can't do it. So Eckstein didn't let go. He said, he came up with a brilliant idea. And the brilliant idea that is insistent until today, we'll see the limitations of it in a moment. But, which is the following. Let's test everybody. Instead of giving you an answer, we'll give you a number. We'll give you something like a social security number. When you come to get married, so you and the potential bride will come to the central office, and they have it on stored on their computers, all of the numbers, and they know which number is a carrier. You don't know, you just got a number. But they know which numbers are carriers and which numbers are not carriers. And they'll put the numbers, your number is 1, 2, 3, 4, 5. Her number is 8, 7, 6, 5, 4. We'll put them into the computer and we'll see, is there a problem or not? The computer will either say, it's fine, shidduch's fine, or the computer will say, oh, there's a problem. So we've stopped the marriages that will create sick children, but we haven't made mishpachot and we haven't tainted you. And he went back to the Rabbanim, and the Rabbanim said it's a great idea. And Rav Moshe Feinstein has a very famous tshuva in which he says not only is it a good idea, but anybody who doesn't do that doesn't have faith, he is stupid. He says that tamim tiyem Hashem Elokecha, to go through with God humbly or tamim completely doesn't mean walking through life blindfold. It means if you can check something out, you better check it out. If you can't, don't do it. But a person can't say, I believe in God, I'm going to blindfold myself and drive from here to Yerushalayim. And he ever said that if Hashem wants me to hit a car, he'll let me hit a car. If he doesn't want it, doesn't. And that's a great idea. You could do that. And when the police stop you, and they pull you into court, then you'll have to explain why you're driving with a blindfold. And if I was the judge, I would put you in prison. Because that's a great thing to do. So to walk blindfold isn't the way that we have faith in Hashem. We have faith in Hashem to do what we can do, which is, I think, very important, because what we're saying is that if we have this knowledge, you're talking about, how is knowledge going to be abused? Having this knowledge is very, very important, and it can save lives. So we have today something, and he called it Dor Yesharim, and it's an organization that's existing today, and it's expanded its thing known from Tay-Sachs, but they carry about 12 genetic abnormalities, and it adds every so often adds more. And they test people, and we've eradicated basically Tay-Sachs from our communities without killing one child, without terminating one pregnancy, just by not getting carriers to marry each other. And there's no other comparable organization in the world. And when I speak to my non-Jewish colleagues about how do we deal with genetics, talk about understanding paradigms and how we're going to deal with genetic abnormalities, and we're going to find more and more since we test everybody's genome. So when I speak to my non-Jewish colleagues, they're in awe, and they are jealous of our ability to have something like Dor Yesharim, which can basically eradicate genetic abnormalities. What's the limitations of Dor Yesharim? So there's several limitations of the following. The first is, of course, it's only good if you are not going to get married before having your numbers checked out. But if you have a girlfriend that you met, you've been friends for 10 years in high school, and then you grow up together, and then you go through Shiva, and then you get married, so they're not going to break down that shidduch, because you're not going to say, well, only going to get married if we've got the right numbers. You're already an item, and that's not going to solve the problem. It's great in the shidduch world, in a world in which people only start even thinking seriously about even going out when the numbers tally. That's a great thing, but it's not always good in all communities. The other thing is, a lot of times, I don't know what's the norm in your communities, but in my community, here in Modiin, it's extremely normal to have Ashkenazim marry Sfardim, or Sfardim marry Ashkenaziyot. It's a perfectly normal procedure. Now, it's not the same in a lot of more Haredi communities. That's not always the case. In more Hasidic communities, they only marry really within their own ethnic background. But we don't always do that. And now, Ashkenazim and Sfaradim have different genetic abnormalities, so we can't always test only the Ashkenazi genetic abnormality, because there's also a whole string of Sephardi genetic abnormalities. They're not always the same. So that's another limitation. And a third limitation, yeah?
I would think that would actually reduce the risk, because if they have abnormalities A and you have abnormalities B, the likelihood of both partners having the abnormality.
There are things that are more rare in the Ashkenazi community, and therefore they didn't hit the par which Doishem will test them, but they do exist in Ashkenazim, but less. So that we haven't tested Doishem, and therefore they sort of they went under the radar. It's not so common, but there are cases.
What do you do in the communities that like the girl and the guy are together for a long time? They're not going to say, what do you do?
So we're going to speak about that. That's the next part.
Oh, okay.
And the third thing, of course, is dominant genetic abnormalities. If you've got, if in your family you have Gaucher is one of the muscle wasting diseases that people are born healthy and then the muscles break down and then they end up in a wheelchair. That's a dominant genetic abnormality. You can't get that out by not marrying someone who doesn't have Gaucher. It doesn't help you. So for those people, the wider community and the mixed community, and for dominant genetic abnormalities, we don't really have a Doi Sharim style solution. We have something else. And we have today something else, which is something that we'll speak about for the next few moments, is what's called pre-implantation genetic diagnosis, otherwise known as PGD. Pre-implantation genetic diagnosis is the following. On July the 25th, 1978, a little girl was born. A little girl who changed the world literally. And her name was Louise Brown. I don't know if her name is anything to any of you, but to you I hope. Louise Brown was the first child born. She was born in a London hospital, born after a procedure called in vitro fertilization. Or otherwise, she's the first test tube baby. In vitro fertilization, what happens is the fertilization takes place ex vivo, outside of the body, and not inside the body like all of us, we assume are conceived. And as some of you also born from like that. The procedure is that we have sperm and egg meeting in the lab. We now have fertilized egg in the lab. It develops there. Now we can almost grow it almost for 6 days, plus minus. So we have it in the lab for a few days, and then we reimplant it into the woman, and she carries the baby, and she hopefully carries full term, and she gives birth. During the time that the fertilized egg is in the lab, what is a fertilized egg? Well, sperm contains 23 chromosomes, egg contains 23 chromosomes. When they put them together, fertilization, we have 46 chromosomes, and that immediately starts duplicating itself very, very quickly. And it grows at an incredibly quick rate in the first few days, and continues growing at an incredible rate, which slows down later on towards the birth of the child. So in the first few days, we have a big ball of cells. That big ball of cells contains all of the genetic material that will be in the eventual child. So here I have, like I can do a blood test on myself, I can do exactly the same thing for the ball of cells. I can remove a cell. I can amplify the genetic material, because I have a very, very small amount, in a procedure called either through something called PCR, or now we do it through a computer called microDNA arrays, that we can amplify the DNA, and we can now check it now for markers pre-implantation, before we put it back in. So we can take a husband and wife, we can get a pregnancy in the lab, we can test the embryos, and we can remove that dominant genetic abnormality. We can remove the genetic abnormality they have because they have Tay-Sachs and yet they were going out and if they got married. I just met recently, I was in America 2-3 weeks ago, and a woman I was eating a meal somewhere, and a woman came up to me and said, you don't remember me, but you cancelled me a few years ago. My husband and I both carriers of Tay-Sachs. Young, normal, modern Orthodox couple, and we cancel what we cancel. They have 4 healthy children now. So that's the solution we have. PGD is the science of today, but it's also the science of the future, because we're going to be using it more and more and more. And the question that we have a lot of times in thinking about genetic counseling is who should be using this procedure and who should not be using this procedure. We just published an article in the Journal of Genetic Counseling about genetic counseling for Jewish religious couples. What are we using genetic counseling for? What are we using PGD for? What are the parameters? What are the paradigms we're using? And we'll present some of the cases that we said there. So let's think of a few cases where PGD would be very, very useful. Well, dominant genetic abnormalities is one of them. But what about doing for something else? What about using PGD not to eradicate diseases per se, because I think everybody agrees is a good idea. But what about for eradicating carriers? Not to create, remember we wanted to create Mishpachat Anefim. Let's eradicate carriers of genetic abnormalities. Now if we have two parents who are carriers, we do IVF on them, in vitro fertilization, we do PGD, we have the embryos, there are a percentage of that embryo, of those embryos, which will have no genetic abnormality at all. Not only will they not be ill, but they won't have any of the affected, what we call alleles, the affected half strands of DNA. So maybe we should be doing PGD to eradicate not only illness, but carriers. And then in 3 or 4 generations, we won't need to do any PGD, that we know carriers left. So who thinks that's a good idea, that we should be doing PGD too?
Sounds cool.
Yeah,
That's
sounds
helping.
pretty good.
Sounds a good idea.
But that only helps people who are doing in vitro fertilization.
The problem is, very smart, is that means we have to do in vitro fertilization. Right? So now, which means that we're going to do a lot of genetic testing, and we're going to find a lot of people who are not even both carriers. What if one of them's a carrier? So if I'm a carrier of Tay-Sachs, my wife is not, we won't have any children of Tay-Sachs, but I want to do PGD to make sure that none of my children are even carriers. So now we're going to start doing much, much more in vitro fertilization. So is that a good idea or a bad idea?
Well, what's wrong with it?
So what's wrong with it, you could say? Well, maybe there's a risk involved. We just presented a paper. We just presented a paper in London in the European Society of Human Reproduction and Embryology, which is the largest fertility society in the world. There were 10,000 people at the meeting. We presented a paper about risk, about how do couples look into risk. There is risk involved. There is risk involved in doing a fertility treatment. Not only that, there's risk to the mother. There's risk to the unborn child. So the risks are small.
I don't like it anymore.
What?
I don't like it anymore.
Oh, you don't like somebody squint off it. Should we be doing elective surgery at all? Elective surgery includes even the simple procedure of going under anesthetic. We have a general anesthetic. It's a small one. It's a very simple one, but that's still potentially dangerous. So that's a good question. The question comes up not only regular carriers, because the truth is that for regular carriers they have Tay-Sachs, no one's going to do PGD. But there are carriers that has an impact. For example, to be a carrier of cystic fibrosis, certain types of cystic fibrosis, which affects lungs. Now you can be a carrier means you don't have the disease, but being a carrier of certain types of the mutation creates something called CAVD, a congenital absence of the vas deferens, which is the tube that takes sperm from the testicle out of the penis is missing. So you're not infertile, but the only way you're going to get a pregnancy is by getting sperm out of the testicle, which is a whole question of itself. So do we do PGD to solve not CF, but to solve CAVD? Not to solve cystic fibrosis, but to solve this other problem, which is a fertility problem, not having a vas deferens. So that's a question of itself. But it's a greater question in our communities that doesn't affect, hopefully, too many of you, although it can affect men as well, but mostly affects women. There's something called BRCA. The BRCA mutation is the following. Everybody in their body, everybody here has cancerous growths. Everybody. What happens is our body keeps them in check. Our body has a mechanism in our body which is that when cancer starts growing, our body breaks it down. It either mends the cells or kills the cells. There are men, but there are some men. I have a man in my community who has BRCA mutation as a man, which means he's at a greater risk. We'll see in a moment for what. But it's mostly found in women, especially in Ashkenazi women. There's a mutation called BRCA, which is the inability to break down that mechanism doesn't work. And therefore, they're at a greater risk of getting breast cancer, of getting other types of female cancers. So this guy who has BRCA, he has a greater risk of getting breast cancer.
Oh, I was going to say prostate. I thought it was
Right?
prostate.
No, it has a greater risk of getting breast. Now, men can also get breast cancer. Right? You can get a growth and you get breast cancer. You want to say something? No. Oh, you just stretching. Sorry. No, that's good. Yeah. So, having BRCA as a carrier, you're born with it. It doesn't affect your life. When you get into your mid-40s, you're at a much greater risk. Now, should we be doing PGD to make sure that we eradicate BRCA as a carrier? Now, it's a genetic abnormality that really doesn't affect you until 40 years later. Should we be doing that? That's a huge question today. So you think yes? You think who said something? Yeah? You think should be doing it? Back to you. Yeah? You think should be doing it? All right. Everybody agrees with you?
Yeah. Right.
We should be doing it for BRCA?
Yeah.
You think no? Why do you say no?
What?
You think no?
I think no, because I think the whole process of the DNA testing. I think a lot of the criteria that were given to do the whole to do whatever works out. And Buddha has great ways of doing it.
Medical question or halachic question?
No, I'm saying halachic wise. I think a lot of the criteria were given were for cases that were problems. People couldn't have kids. People had trouble having kids. People were in danger. But to start doing it for everybody, just start getting rid of things. I feel like that's not what the criteria were given for.
All right. So you're saying basically that we're worried about a slippery slope. That if I say you can do it for that, then tomorrow we'll do it for blue eyes, and for athletic build, and for higher intelligence, and we'll become like the Nazis.
I don't know that whole Nazi thing, but is that a halachic problem to start giving people blue eyes and things?
The question is, are we permitted to undergo elective surgery to create the perfect child? And we know, we wrote this in our paper in the journal of Genetic Counseling, that Chazal never said we need to get perfect children. We wanted to have healthy, even not getting mishpach nefin doesn't mean to be perfect. Because we know there were lots of the Tanaim and Amorim who were blind, who were short, who had all sorts of other health problems, and that was perfectly normal. That wasn't considered to be anything problematic. The fact that you have a health problem. So, did Chazal want us to create the perfect child, and can we create a perfect child? And what we don't know is the balance of the world. So we don't know when we do something here, how much we're affecting here. There used to be something when I was a kid.
It works.
When I was younger, we were seeing the results of that. But about 50 years ago, there was a medicine given for women who had recurrent miscarriages, right? Called thalidomide. That was what it was, and it was a wonder drug. And women were having recurrent miscarriages. Gave them thalidomide, they stopped having recurrent miscarriages. The problem was, and it only was seen much later, was that the children were born with very, very short limbs. So I remember having a madricha when I was in school here in the 70s. So we had a madricha who had one very, very short arm. Her mother took thalidomide. There was something else called DS, which you also gave for the same thing, which created women with abnormal uteri. So we don't really know the balance. We know we're very smart in doing this, but we don't know the balance. We say every day when you come out of the bathroom, you say, Rofeh chol basar umafli la'asot. God heals all flesh. And the truth is that today we understand that bracha because doctors become so specific, they'll be so specified in one area that they can treat you here, but in fact they mess you up somewhere else. So they treat your fertility and they give you cancer. Or they treat your cancer, but they mess up your liver. And HaKadosh Baruch Hu is Rofeh Chol Basar. HaKadosh Baruch Hu actually heals all flesh. He actually makes us really healthy. So maybe God's will is we should leave it on some level.
Yeah, there is a risk.
There's always, everything is a risk. We don't even sometimes know the risk.
So you don't know the risk.
We don't always know. Like we didn't know with thalidomide that was a risk. We knew it later. We didn't know with DS there was a risk. We knew it later. We don't know always. Yeah, you want to say something in the back? Yeah.
So why aren't non-Jewish or non-religious parents making perfect kids?
Why are they not? So the answer is that they're going to be more and more they will. And the genetic testing and doing PGD and its cousin, which is PGS, pre-implantation genetic screening, is becoming more and more the norm. We're getting to have more and more IVF. I mean, I'm saying, you have a group here. I speak to groups your sort of age, and now I'm starting to get kids saying, "Yeah, I was born from IVF." Everyone's like, "Oh, wow, that's cool." In 20 years' time, I don't know if I'll still be here, but given this talk, but some of you will still be here, and I'm going to give the talk, and then one guy's going to go, I wasn't born from IVF. You're going to say, wow, that's cool. Are you normal? Can you reproduce? Like, everybody's going to be IVF. So we're going to get more and more IVF. That's that's what's already happening. If you're in America and you're getting married in your 30s and you're planning on having 1 or 2 children, the chances of you doing that with some genetic testing is extremely high today in certain areas. So if you're in sort of New York, California, the chances of it happening more. We're getting much, much more fertility than we used to. And in Israel as well. Yeah.
No, I mean so by perfect children it means health-wise, they can't like I'm saying, parents create a incredibly smart, incredibly good looking, incredibly athletic. Like
Can we
everything.
now, but not 100%, but we'll be able to in the future? The answer is more. We'll be able to do genetic engineering and create and take out the genes that we think are problematic. But we only think that, but we don't know if that's the case. We think that we don't like those genes, but maybe there's a reason why those genes are there, right? There was in fact a discovery about a year ago. We used to think that the gene has a lot of wasted space. You know, if you take any book, at the end of the book, there's always like a few spare pages. At the beginning of the book, there's a few spare pages. So we thought the genes were the same. It's like a few spare pages at the beginning, at the end, in a million. They just discovered now, they did research, and they just discovered, just published in Nature, that really there is no wasted space in the gene. The genome, every single part, every single sugar, every single protein pair determines something to do with your body. So we didn't know that a year ago, right? You have those things on your... What did we know last week? We didn't know that a year ago. What will we know in 10 years' time? We don't know. And so much that we don't know. So as I said about BRCA, we said, well, we should do genetic pre-implantation genetic diagnosis and not put that being BRCA. What we don't know is these women are going to be born healthy. They're going to be at a risk in 40 years' time. Who says where cancer research is going to be in 40 years' time? Maybe we're going to have a much better solution. Think how where cancer research was 40 years ago, and think where it is and where it's going to be in 40 years' time. We don't even know what gene therapy we're going to be able to do, and what you're going to get cancer. You take a pill and you'll be fine. So to try and eradicate something that's later on, that's already a big question. We'll take maybe one last case, and then if you have guys have questions, we'll close. The most simple thing we can do is if we can choose genetic traits. The most obvious genetic trait for almost everybody is gender, right? We can choose male or female. That's very easy. That's XY. If you're XY, you're male. If you're XX, you're female.
You
So
can
that's
choose that for the woman?
You can choose that for the embryo. We'll get a couple. They get pregnant. Well, they won't get pregnant naturally. We'll get pregnant in the lab. We'll have a fertilized eggs, and we'll only put back whatever we want. We want boys, we'll put back only boys. We want girls, we'll put back only
Do
girls.
people give like requests like we want a girl?
Sure.
That's really
Sure.
weird.
That's really weird. Can
it
we do
doesn't-
that? Should we do that or not?
No. Yeah,
No?
I'm not feeling it.
Yeah, why not?
But people who said why not? Yeah, if you do it for BRCA, why can't you do it for a boy or girl? This thing sounds weird. Just
The risk seems like
it creeps us out.
it could outweigh just
No,
having
if you're
people
already
do
doing
a
it,
girl.
then-
Not for a couple that really want to have
Does it mess
that
up
gender.
anything?
They don't know.
We don't know. We know a little bit. We don't know 100%. Yeah, it doesn't mess up something. Yeah, you have a greater chance of having a congenital genetic abnormality. But I know there's a kid in this city who was born some years ago with a sixth finger. He was born from IVF. He was born with 6 fingers. He had the 6 fingers removed. He doesn't know about it. And one day I saw him and I checked his hand and I turned his hand over and his mother says to me, he doesn't even know that he had that operation. And you can't even see anything left. Having a 6th finger is a pretty serious genetic abnormality, but it has no relevance to anybody's life. So now he had 6 fingers and now it's 5. It doesn't make a difference. So there are genetic abnormalities which are
How long
relevant.
has this been around for?
What, IVF?
Yeah.
They said the first was born in July 25th, 1978.
Right, so
So we've been doing it for a long time.
I've been here for a long time. Okay, so you
But
already
we don't-
said the people who are older.
Yeah, we have already, the first IVF baby already has their own babies, naturally. So we already have IVF kids who are out there, yeah.
When they go ahead and they put the embryos and the sperm together, the sperm is what determines gender. So do they know before even putting them in there that this sperm is male and this sperm is female automatically?
We can do. That's usually not what's done.
Or
We can do that. There's
or
a-
through the parents requesting, oh, please go ahead and.
So what happens is that what we do today is that we will create fertilization and then we'll test it afterwards. But we can't. We don't really test the genes of sperm
automatically.
Yeah, we're not really at that. There's something called microsol. They used to do it that way. We don't do that anymore because it wasn't seem to be particularly effective. Yes.
If you pick out like only the boy ones, or
Yeah.
when it was supposed to be a girl, or
Yeah.
will that boy be born with some like female traits?
No, we're gonna. That's the thing. So we'll not do that. We'll do regular fertilization.
Yeah.
We'll put it in a lab, and we'll just say this is male. We'll keep it, and this is female. We'll throw it away, or we'll freeze it. Maybe we'll
Save it for another day.
save it for another day. We'll save it for another couple. Yeah.
Just because of what you're saying, Just something that you mentioned before. Firstly, you said somebody. This is not like a genetic kind of question. Somebody who is born, a boy is born and he doesn't have a brit milah. You said that he's chayav cars until he's 12.
After his bar mitzvah, after his bar mitzvah, it's his responsibility. I know a number of people who came to have brit milah afterwards. Their parents didn't do brit milah for them. They had their brit milah afterwards.
Also.
Sure.
So,
yeah. You want to say something on that?
It wasn't on that, it was a different question that I had.
Okay.
So, did you mention before, like, I don't really notice it anywhere else, but I do have observed it mostly in this kind of scenario that most religious families who have a lot of children, some of them tend to have, I've seen more, just mostly
genetic abnormalities.
Yeah, some kind of genetic.
So that's related to something else. We know that as a woman gets older, her eggs get older. And we have what's called aneuploidy. That's not to do with inherited genetic abnormalities. If you have we have pairs of genetic pairs, right? There are an abnormality where you can have a triploidy, which means instead of having one parent, let's say 18, you can have three. 3 pairs at 18 is not compatible with life. That's called trisomy 18. It doesn't exist. But trisomy 21 does. It's called Down syndrome. You've probably heard about that. So Down syndrome is a trisomy at stage 21. That can happen in all trisomy. You can have trisomy in all of them apart from 17. Past 17 we don't have trisomy.
So it's because they just have children late?
Because aneuploidy is more common with a multi-parous woman, when a woman has a lot of children who is older. So that's why it happens. That's why usually you'll see it. It's not always, but you do see it. Okay. There are also some families that if your cousins marry each other, you have a greater chance of having abnormalities. So you have certain families that sort of tend to marry each other within the family, then you get a lot of genetic abnormalities.
And what you were saying before, his thing, he asked what if so they're making progress in this idea that you can choose different characteristics for people.
Right.
How far are they in that kind of process?
Well, we've got to the point that we can screen for pretty much any genetic abnormality that we know about. Are we going to do genetic engineering?
Like be able to make them stronger? Yeah.
Probably. We're going to get to that.
How far are they in that? Like,
it's not clinically practical at the moment.
Are they testing it?
It's testing. All right, it's being worked on. You want to say something?
How do let's say as far as just yichus yichsin issues. So let's say you have someone who's a kayan or a lady. So what's the guarantee? I've heard of story. It's been this is really awful. Well, people will switch sperm and all these types of things. So what do they do? As far as to guarantee this is this mother's egg. This is this.
So we said before you came in that we have supervision of fertility treatments to ensure that no mistake can be made in the lab, and we prevented mistakes like that. To say that there's absolutely no question. I know a Kohen who has no children, and one of the reasons he doesn't have children is he's very frightened that in the lab there's going to be a mistake and his child won't turn out to be a Kohen. Now there are poskim who say that in any case in IVF the child won't be a Kohen if you're a Kohen. There are poskim who say that because that's Kohuna is only conveyed, maybe you could say, through regular conception. That's extremely, today that's not the norm. The normal psak is that it is. And we have supervision to ensure that there's no mistake.
So if the kid gets a certificate, the family gets a certificate?
The parents, we don't give out certificates, but the parents know that there was a supervision. We had cases, someone came back. Someone came back and said, what happened, we have, everything is logged. So a couple come back and say, 5 years ago we had a treatment. I can tell you where the treatment was, how many embryos were produced, who the supervisor was, what the procedure was. So I can log it. So in cases that we have a log of 15 years of treatment. So we can go back and say, this is what you had, this was. Yes?
Why are they trying to make why are they trying to test to make superhumans?
So we're not trying to make superhumans. What we're trying to make, it sounds like superhumans
I'm saying that you can make anybody perfect.
What we're trying to do is the following, because more and more people are using in vitro fertilization. And we want to get away from the possibility of having, the least as possible, having multiples. Because multiples isn't good. So they have
multiple children.
They have at one point there was the octomom. Don't you know about the octomom in California? So she had 8 embryos at the same time. That's not a good situation. She happened to be very, 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 very lucky. But the norm is that doesn't happen. So we want to have not a multi. We don't have to have as many children as you want, but have them, 1 or 2 by a time. So we don't want to have multi-fetal pregnancies. So because those are dangerous, because those usually do not go to full term, because they often miscarry the whole thing. So to prevent that, we're trying to get through IVF to get to the having the least number of embryos we can put back. In fact, the dream today is to have what's called SET, which is single embryo transfer. Now, to get to have single embryo transfer, I've got to be ensured that the embryo that I'm transferring is going to develop into a pregnancy. So we've now had, in the past year, there's a new instrument on the market called an embryoscope, which basically is the ability, or the computer tries to help us to choose the best embryos. Within that, since we spoke about aneuploidy, if we have a woman who's older, I'm going to test the embryo as well to make sure it's not aneuploidy, because aneuploidies don't grow to be babies. So we're not, I want to get the perfect child, I want to get, my children, or I want to get a Nobel Prize winner. That's not what it's about. What it is about is getting the best chances of being successful. That's the things happen to come together, because if we get a healthy embryo, then it's likely to end up with a healthy pregnancy, which is more likely. Will we ever come to choose in the books? Yeah. In sci-fi fictions? Yeah. Will we do it in real life? On some level, it will look to the layman, yes. Will that be the aim of most fertility? The answer is no. Today.
But they will be able to do it.
We will get more able to do it, yes.
A better percentage.
So it looks like it.
A better percentage.
And we'll get better percentages of yes.
How is it in terms of dominant recessive genes? Like my father, my brother, and myself, we all have dark hair and dark beards, but a lot of times in our beards we'll get a few red hairs. So how does that happen?
So it's a good, because hair coloring is, the hair coloring is a slightly complex. Hair coloring and eye coloring are actually much more complex than we think. They're connected to not a specific gene marker, but they're connected to what's called a cluster of genes. So there are gene markers that deal with hair color, but they're turned on and off in a more complex way. So you're going to have colorings that are it's usually we're not monochromatic. We're not white or black. Usually a grade of coloring. That grade of coloring is dependent on a cluster of genes, and so we don't really have a marker for all of those. There's not everything we have markers for. Not everything we know. Not every illness we know certain things that have. So, for example, autism. Autism we don't have a marker for. We have a cluster of genes that seem to be common for boys with autism, but we don't exactly know a marker. Oh, if you have this, you've got autism. It's not exactly the case. Yeah.
PTG right now is only done in the lab, right? Can it be done eventually inside the woman's womb?
Well,
because a lot of people have normal pregnancies,
and they
were afraid of Down
syndrome. We can test today genetic abnormalities.
Now, if you know you have Down syndrome, so
you have to terminate the pregnancy. But what will happen, or what we may be getting towards, this is now in the past 2 years, something called NIFTY, which is a way of testing the blood of the mother to see the blood of the child. So it's not an amniocentesis or a chronic ciliary sampling, which are dangerous. It's a blood test. And the idea, we're going to be able to do that earlier and earlier and earlier. So if we get to the point that we do that very early in the pregnancy, it's not really a termination. Before 40 days, let's say, right, or before 3 months, it's not really a termination. So we're going to get to that in vivo, and ex vivo we have PGD. So, yeah, last question maybe. Yeah.
Also, if let's say you have the couples who live in out-of-town communities, or let's say they don't have access to your organization,
right,
and they're a from couple and they want to do IVF because they're not able to do any other way. Do they have the right to rely on a doctor who's not Shomer Torah mitzvahs to go through this process?
So supervision doesn't come to say that I think you're a cheat. Supervision comes to eradicate human error. Rav Elyashiv said to us that if I was working in a lab, you need to put hashkafa on me as well. Not because I'm not trustworthy, but because I'm a human being and I make mistakes. So the truth is that we've been in North America. It's a bad example because North America we've really been to pretty much anywhere that any Jew would live, and that's the only family living there that I can get there as well. We have about 65 labs in North America that we work with. So we've been to couples in the sticks, and they need one treatment. We'll send a supervisor there. We'll fly her in I have supervisors all over the country, so it's not a problem. I'll fly her in. She'll go into supervision. She'll come out. So there's no reason that the first couple shouldn't. There was a rabbi said to me, one of the rabbis in North America, quite a famous one, said we don't need to do supervision. We can do DNA testing. Let the couple get pregnant. They'll give birth, and we'll test DNA if it's their baby. And I said, okay, and what will happen when they test and they find it's not their baby? What then? So he said to me, I've never had a case like that. So I said to him, yeah, because the Rav doesn't work in Puah. So you have, how many cases do you have? He has a case a month, he has a case a week. We have 185 calls a day. So anything that he sees in his lifetime, I see once a year. And anything that he sees once a year, I see once a day. So we have the huge, you can't, the way to do it is supervise. And it's doable. I mean, we're doing it. So. Top, thank you very, very much. So, Tovot.
Thank you.
We'll keep some of the questions that maybe come back.
Absolutely.